Today, we are investigating the shocking deaths of 64 feedlot calves.
What do you know about their history?
Well, we know they all had chronic antibiotic-resistant pneumonia, and right now our top suspects are Mycoplasma bovis and BVDV. They may have been acting together.
Let's start the autopsy to look for lesions in the lungs and hearts.
I'm seeing a number of acute and chronic lesions in the lungs. I'm finding raised, firm nodules on the pleural surface of the lung, and fibrinous to fibrous pleuritis.
Me too. We better take heart and lung samples for histological analysis.
Great, and I will do a bacterial culture.
Alright, I've stained the samples with H&E. Look at these myocardial and mnemonic lesions.
I would say those almost look like severe, necrotizing, suppurative bronchopneumonia with bronchiectasis.
What did your bacterial culture show?
I isolated a number of bacteria from some of the calves, including Mycoplasma bovis from 90% of them.
Ideas mio, just as we suspected. But it might not have been acting alone. I still think we should run some immunohistochemistry to look for BVDV.
Alright, here's the monoclonal antibody for BVDV, and the horse anti-mouse serum secondary antibody.
Look at that! Some of these calves are positive for BVDV too. About 60%, I'd say.
Do you think they were acting together? Let's go over what we know about the way they cause disease. What is M. bovis anyway?
Well, it's a bacterial pathogen, but what makes it so hard to fight is that it lacks a cell wall. And as you know, beta-lactaminox target cell walls, so this guy is resistant to them. The complete pathogenesis is unknown, but it's able to adhere to neutrophils and macrophages and multiply on their surface.
It causes pneumonia and mastitis, right?
Yes, and arthritis, genital disorders, and abortion.
My God, what a horrible pathogen. How is it typically transmitted?
It infects young calves either through infected milk or contact with others.
So these calves in the feedlot probably didn't stand a chance.
No, and even though the BVDV wasn't found as frequently, it still may have played a role. What do you know about BVDV?
Well, its full name is bovine viral diarrhea virus, so I think it's safe to assume it's a virus. It also has two biotypes, one that causes cytopathic effects and one that is non-cytopathic.
And I'm going to guess it causes diarrhea.
Yes, but the clinical disease can range from a mild cough to fatal mucosal disease.
How does it cause infection?
BVDV replicates in epithelial cells in the tonsils and nasal mucosa. From there, it spreads to lymph nodes and causes viremia, and the virus invades many tissues.
I remember the strange thing about BVDV is that calves show acute disease from the cytopathic version, only after being infected by the non-cytopathic version first.
Yes, a persistent infection of non-CPE virus causes immune tolerance, and the immune system doesn't recognize the disease.
It suppresses the immune system, which would allow a secondary bacterial infection like M. bovis to get in.
Oh dear God, it's horrible.
Oh, that CSI network. What a downer.
I know, that really bums me out.
Let's change the channel.
Okay. We're here to see if the rumors are true. If a positive and synergistic relationship does exist between BVDV and BTB. I know you're all dying to find out, so we'll get right to it.
Viewer discretion is advised.
1 year ago today, 12 brave calves volunteered to take part in a study that aimed at answering this much-thought-about question. These calves risked their lives for their fellow bovine in hopes of developing a vaccine that will one day save all of us from bovine tuberculosis, and we are grateful for them.
They were housed in a very high-tech facility. All calves were given intranasal Mycobacterium bovis suspension. Just 6 were also given a sub-Q injection of bovine viral diarrhea virus. Then our top scientists monitored nasal secretions to check for shedding patterns. Unfortunately, results were not conclusive. We found that shedding of the bacteria was intermittent and very cat-dependent. There are so many variations of immunity and genetic resistance that need to be considered. Essentially, there were slight differences between the two groups, meaning bovine viral diarrhea virus should theoretically make shedding worse. However, the results were not statistically significant. These calves did help us more fully understand the pathogenesis of BTB, which is that after exposure via aerosols, the bacteria set up focal spots for infection, which then release more of the bacteria back into the respiratory tract. I know that this information will be very helpful to us in designing future studies and possibly in developing a vaccine.
I am sure it comforts you all to know that our fellow brethren did not die in vain. They have helped us understand the unknown dangers of two very serious diseases. But now I wonder, what makes these diseases so bad?
What an astute question, Bovine Brokaw. These diseases are so harmful because both diseases are associated with numerous virulence factors. Virulence factors are molecules expressed or secreted by a pathogen that produce disease in the host.
Wow, that sounds like a little war going on my insides.
It is like a little war going on inside of you. For example, M. bovis evades the host's immune defense systems. It can inhibit phagosome-lysosome fusion and reduce the pH in phagosomes. It also inhibits production of ROIs and produce enzymes that degrade these microbicidal host metabolites.
Wow, that is a lot of virulence factors. But you forgot to mention BVDV. Can you tell me about those?
Oh, of course. The virus inhibits the induction of apoptosis and the expression of interferons. It also has a special non-structural protein, NS3, that's required for virus replication.
Ah, Gene, that was sad. All those calves with fevers, and they were skinny, and they were lethargic. I never want to feel that way. Good thing we've got good genes, Gene.
You're right, Midge. Let's stop trying to educate ourselves and watch some MTV